going to start with a simple application, but obviously we can support a lot more complex applications. This specific application is the V function backend. I can show the tech stack and the names of the services.
Yeah, that'd be good.
So you see here, there's some services. There's also logic to how these services are displayed. So every bubble here is a service. As you see, they're all Go services, Golang. So all the OpenTelemetry languages, all the languages that are supported by OpenTelemetry are supported as well. There's logic to how these services are displayed in terms of layers. So we try to make sense of the architecture by putting them in layers based on the direction of the dependencies, trying to get to an architecture where there's vertical separation. So there's horizontal separation. So every layer does something different, and dependencies go down between the layers and never across layers. So to make sure that scalability stays high, resiliency stays high. The color indicates the percentage of resources that are used exclusively by that specific service. In most distributed environments, you want to get close to 100%. Here, this specific service, the users one, you see it's blue. Blue means that only it's a medium exclusivity. So about half the resources used by this specific service are used non-exclusively. So they're used by other services as well. Now, so here until now, what you see is basically a similar picture to what you can see from an APM or from the configuration you have in, I don't know, like an API gateway. Of course, without the colors and the sizes. The size is also the centrality of the service, like in how many flows is that service present. In a good architecture, you don't want specific services to be overly dominant. And we can start focusing in on specific flows. So for instance, I can hover over this line and see that from the distributed service to the organization service, there's 3 APIs. When I click on the details of the API, I can actually see the sequence diagram. So this is a sequence diagram that gets generated automatically. So this is really architecture, your live architecture. So unlike an integration with LeanIX and CMDBs, where people actually have to put stuff in and no one knows what the actual interaction. This is based on actual interaction. And this can be also exported as a Mermaid script, put into your Confluence. So this is really architecture as code. This is not the last time we'll see architecture as code.
I'll interrupt you, but make sure I understand that there. So from a GraphQL and the subgraph problems that we have, if any endpoint made a call into these at one point, it would show up and get added to that as part of a sequence diagram as a possibility for these new calls. Would it be an independent node, or would they share sourcing under the nodes of these?
What I'm not so sure of is what exactly is the support of OpenTelemetry in terms of understanding the query inside the GraphQL. There is specific support for GraphQL within OpenTelemetry, but I have to say that I just don't know what the answer is. Like if we won't see obviously the URIs, but maybe we will see something else. If we wouldn't, then for these, what you'll see here is a GraphQL to a service from the user, and here alternate behavior. So you'll see opt and out and
exactly. That's kind of what I expected. That I just kind of wanted to add. That seems to me like the worst case of what I would expect it to do automatically, which is bad anyways. But okay, all right.
But we can act. I already wrote it down for myself to test it in our lab to see what it would do.
Cool.
And so we'll let you know.
Appreciate it.
You can filter in on, so this is like the documenting of the architecture, understanding the architecture. Another piece that I can show you is that we can also export this architecture So these are, of course, containers in the C4 world. So we can actually download a C4 diagram. So when I download the C4 diagram, there's the PUML that I can show here, and you see all the relationship and the relationship in containers and external containers for the database dependencies. So everything is here. So you actually can export this into as a C4 diagram into your systems. You can also import a C4 diagram into here and create a reference architecture and then compare your reference architecture with your actual architecture. And the differences you'll get as to-dos, and we'll see the to-dos pretty soon.
Interesting. So we could import one of the shitty C4s that I mentioned earlier against when
Yes.
you're auto-generated, and you're going to show me the differentiator, right?
Yes.
Okay.
Do you guys have a demo for that? Because like
I was about to say, if you got that
yeah, like I want to
alone,
see that.
yeah.
I have not prepared to show
That's
that
totally fine.
now.
Yeah,
That's fine.
that's fine. But that's I
What I
tell you
Even
this,
think,
if even if I tell you that Lee and I have sacrificed to the demo gods today, you're still
yeah, yeah.
um,
sorry.
it is a cool functionality because when you write those C4 diagrams, I think even exporting this is actually valuable because whenever you do like auditing and you have your PCI audits and someone wants to see how your architecture drifted and they ask you, so people actually update these C4 diagrams without actually knowing what those architecture without knowing the architecture. So just downloading it whenever you want to do your compliance as evidence, that's pretty slick.
Yeah, and I'll ask you, sorry, don't want to break your train of thought, but this feels a good spot to ask it here. The other battle I'm fighting is for documentation in general of code bases, right? And you'd be surprised, but things like Backstage don't have the takeoff that they have here. But in a perfect world, is the idea of this being symbiotic to more of the catalog-based documentation like that and reference links to your C4 here or these calls? When I come to this, is it purely a landing page or are there kind of referenceable sublinks out of this that would take me to some of these nodes and relevantly be documented somewhere else? What do you, is this, do you envision someone landing on this page every time here or relevant linking based upon workload or service or whatever?
I have to say that I don't know yet. In my
Okay.
mind, I see this as the system of record for architecture, for as is architecture. But I also know that you have to put this in documents, you have to put it in your Confluence, you have your documented methods for compliance. So these things won't change very often. So you can definitely link. All these links will get you to these places. So the URLs here are built in a way that if I go to a specific flow, um, then it's
So it's
called,
immutable pathing. Okay. Okay.
yes.
Mhm.
Okay.
Okay.
So you can definitely link it.
Okay.
Here, by the way, in this specific flow, we also see an error, so you can even see errors that happened.
Hmm.
Oh, that's
So
cool.
this is
What does it
That's
look
really
like when an
nice.
error? Yeah. So go back. What does it look like when an error terminates at an API surface? So like it'd be super interesting to capture places where errors are basically being trapped and not properly handled through the system.
interesting. In my mind, I thought that whatever is not actually an error is probably okay because
You know, like
Yeah.
I think between Lee and I think the two of us manage hundreds of apps. So like if you kind of go back and look at it, we're probably talking tens of thousands. So a guarantee that every one of them is behaving right is basically zero.
Yeah.
So you're saying like you would expect that in some of these flows you see that 404 come back and then stop
It's a
before it
200
ever
or something.
reaches. Yeah, it never comes back to the user that way.
Exactly.
Yep.
Interesting.
It would
Yeah.
even
Yep.
come back to the
You've got
user
it.
as a 200.
Yep.
Yeah.
Every damn time. So that would be of interest
Someone's doing Pokemon
in a minute.
exception handling.
Yeah.
Uh-huh.
You got it.
Kevin, your voice is getting a bit better. Um,
Lozenges. Like I'm almost through a whole pack of them today.
Okay, okay,
Yeah.
don't overdo it.
Yeah.
I wrote it down. Okay, I interesting feedback. I've never heard it before. Totally see where you're going. With the flows, I do want to show you like that we're also can focus in on anti-patterns, for instance, circular dependencies. If I just focus on that and I'll see this call with a circular dependency, I can see that there's a call to the organization service, from it to the measurement service, and from it back to the organization service. You can see the double activation here. That's an anti-pattern that can be, by the way, it's not hard to fix. Repeated calls to the same service. That's again extra latency. So you see that there's an optional call to the organization service from the measurement service after a single call that could be done as a single call. You don't need that opt over here. Other examples. Here you see one that got a 404 and then got an OK. And it's not an error because that's the way we planned it. Loops within flows. So here there's something that deletes. So users calling organizations to do an invalidate for tokens and then deletes the user. It deletes two users probably, and it does it with two APIs. It should do it with one.
Amir,
More.
Kevin asked in the chat, how is concurrency shown in those scenarios?
We don't know that it's concurrent, so we'll just show it as two different flows. If things are asynchronous, then we'll see it as asynchronous. So I can find another application, duplicate this. Look for distributed OMS. Sorry for jumping.
You're fine.
Show the names of the services, service labels. Here, in this specific flow, you see that here there's someone is posting to the email topic to Kafka and then pulls it back from Kafka. So asynchronous activations are supported. But if it's concurrent, it'll just show them at any odd order, to be honest.
No, that actually makes sense, and that's fine.
I think we saw that. I'll show you now resource report. We also have a resource report that shows you for specific resources how they're used from the services. For instance, a database table can be used exclusively or non-exclusively. I can filter just the database tables, but I can also filter Kafka and Redis, and then the ones that are used non-exclusively. The ones that are used non-exclusively, it's important both in terms of an anti-pattern and also would you do impact analysis for services. For instance, if a service gets compromised, obviously all the resources that it touches can also get compromised. If someone else pulls information from those same database table, that may also get compromised. So but here everything that's
sorry,
non-exclusive is written.
I'm just jumping back. I didn't miss something on the screen here. I had to walk over to the contractor. This would show potential. Oh, I see. Yeah. Okay.
Yeah.
Okay.
And it's not just SQL tables. It could be MongoDB. It could be Redis, Kafka.
Okay. So
external resources.
Okay.
And
thank you.
And then you can do proper impact analysis for your services. If I want to fix something, I can create a manual to do. For instance, remove this dependency between these services because I don't want it. It'll create to-dos. Another way of creating to-dos, and I'll jump and show you the to-dos in a second. I can create architectural rules. here there are 3 rules allowing the consumer to only call services, to allow the consumer to call any service tagged as an API service. If there's another API from the consumer calling another service that's not an API service, there's going to be a to-do with priority 1. And if there's a core service calling any other service, you'll get an alert and a to-do with priority 2. I can execute a dry run on this specific application and see that I will get some to-dos based on this. So if I apply these rules as a set of architectural standards, or even use the word governance, God forbid.
Can this automatically post tickets to Jira or anything like that?
Not automatically, but manually.
Okay.
So it will automatically create to-dos. I'll show you these to-dos. So some to-dos you get from immediately, like based on the current architecture, and some you get as it drifts. So you can select which to-dos and which events you want to follow, and this is all the list of the events, and it's just quite a big list. Here there's through email, you can also get through Slack. You can do this through an external trigger in your CI/CD. After you deploy, you can run these tests. Through your CI/CD, you can also block pull requests from being accepted if they incur too much technical debt in the form of too many to-dos that get generated. You can configure a schedule to do this on your production or your pre-production systems once every week, like an hour every day, or all the time. And then you get to-dos. I'll expand this.
How does this work if I have multiple versions of an architecture deployed into an environment at a single time?
Into the same environment, because you can tag environments.
Maybe to the same environment. So like, let's say I've got 3 or 4 versions of an architecture running in an environment. Like, is there a way for me to segregate in diff?
Not without adding
does that rely on us?
tags.
Yeah, that's what I was going to get at. Do we have to then like inject OTel tags at the pod level in order to make this stuff work?
Yes, because otherwise it looks exactly the same, because it's the same service name, it's the same everything.
Yep.
It's just different instances. But if you do tag it, then we will be able to segregate it. Not at the moment, but that feature is coming. So you can also create a big application and also look at it as a different subsystems. That doesn't exist yet, but it will be here Q1.
Amir, just a quick time check. We have about a couple minutes left. Want to be respectful of their time.
Yes, of course. So these are the to-dos. So you basically see these to-dos. They're flow removed, recommended refactoring. It gives you some details. You can locate this in the graph and actually see the flows that you need to fix, or dismiss this. Every time you dismiss, this goes into an architectural audit. A feature that I don't have here because it's not linked to Jira is that you'll be able to open a ticket from here, and then you'll see the status in Jira over here. The reason we keep them here is that we can also validate once they're done. So if I remove all the to-dos and look only at the done ones, then I see that whatever's been fixed, I can see, because the system can validate it, because it tests it all the time, right? So you can think about this as positive drift. So I can actually validate these to-dos and treat validated to-dos as or resolved to-dos as reduction in technical debt. So I can actually track the overall level of technical debt of specific systems and subsystems.
So what does the report look like for that? Understanding this is as is in time here. Does it show like over a quarter?
So this is for a set of applications. What you see here, and this is the level of technical debt. Red means it's getting worse, green means it's getting better. The size in terms of the number of services, the number of flows, the architectural complexity. And for a specific application, which I can, what's this one? I can also look at its specific technical debt. Actions and reports, view technical debt report. I don't know what happened to this one. Anyway, you can see the history of it changing in terms of what is the technical debt, what is the size of the application in terms of number of services, the number of flows. Here, for some reason, in the last measurement, the number of flows went to 0. So that's why the architectural complexity is also seems a bit off. But you see, we track things like, and it's explained here, like the layer complexity, the centrality of the services, resource exclusivity, and the dominance of specific entry points in your architecture. We can send articles to explain why these metrics were chosen, but this will tell you.
No, they make sense to me. They're interesting. I'm trying to reconcile this and how we present things through like aggregate CMDB information, right? But you know, that's I'd have to chew and think about that. But that makes sense why you grab these. Yeah. Okay.
Yeah. And I think we're on time. So apologies for taking a little bit too long in terms of.
No, we're asking questions.
Oh.
This is good.
Yeah.
Thank you. Yeah.
Yeah.
Good.